Now that you've learned about quadratics in vertex form, it's time to take a slightly closer look at standard form. Before you do this video, make sure you go back and play with the Desmos graph that's been embedded in this lesson to play around and find out what A, B, and C all do. Once you've done that, come back and we'll go through this video together. So standard form, just as a quick refresher, looks a lot nicer than vertex form. Standard form is ax squared plus bx plus c. No brackets, no subtraction. Seems pretty nice. But now that you've played with Desmos, you've probably got a slightly better handle of things. So let's go over what these things actually do. A is exactly the same as vertex form, so it does exactly the same thing. It controls the direction of opening and controls the width. So nothing new there. B and C, on the other hand, are a little different. B is pretty useless. It does two things. It moves the graph both horizontally and vertically, but not in a way that's particularly predictable. So that's not great. C, slightly more useful, moves the graph just vertically. But it's not like Q in our vertex form. It doesn't tell us where the vertex is. It does tell us something, though, which you may not have noticed. So let's take a quick look at Desmos. Here's our graph, y equals ax squared plus bx plus c. And so right now I've got a being 1 and b and c both being 0. So again, as I change a, graph gets skinnier or wider and flips upside down. Not much new there. As I change b, you can see the graph moves around both horizontally and vertically. It's not getting skinnier or wider. It might look like it. Let's zoom out a bit. It's kind of hard to tell, but the shape of the graph isn't actually changing. It's just moving. So there's not much going on there. Let's just leave it, we'll say at -5. C is the one that at least tells us something a little more useful though. So right now C is 0. And then watch what happens to the graph as I change C. It's sliding up and down, but the number in particular is quite important. So I'll leave it here at -3 for a second. Look around the graph. Why does -3 matter? Well, if we look at -3 for x, that doesn't seem to make any difference. There's not even anything there. But if we look at -3 for y, and we zoom in a bit here, you'll notice that the graph actually has a y-intercept there. So zoom that back out. You can see our y-intercept is -3. And so if I move the graph, now it's 2.6, and our y-intercept is 2.6. So that's the other thing that C does. C moves the graph vertically and determines the location of the y-intercept. Unfortunately, that actually doesn't matter all that much, but it's at least something. It's more useful than B. So there we go. We have A, we have B, and we have C. So you might be wondering how we're going to graph with vertex, or standard form rather. So graphing with standard form. And here's the trick. If we want to graph with standard form, all we have to do is not do that. Graphing with standard form is possible, but it's generally not worth your time. Later on in this unit, you're actually going to find a way to convert standard form to vertex form. So if you ever have a function in standard form that you want to graph, you're much better off converting it into vertex form and then graphing it from there. So for now, we're just going to say we don't graph in standard form. But there will be times when we do want things to be in standard form because it is a little more helpful for representing some real life situations. So if we do have something in vertex form, sometimes we'll need to get it into standard form, so let's see how to do that. So converting vertex form into standard form. There is a formula you can kind of memorize to tell you what your P and your Q values will be. I wouldn't say it's necessarily worth it. It's better to understand how to get there, so I'm just going to show you how to convert directly. If you want to see the formulas, you can look them up in the textbook in section 3.2. So here we go. Let's convert y equals 2 times x minus 3 squared plus 1. All we're really going to do is just follow BEDMAS and simplify everything on the right. So remember, BEDMAS is brackets, exponents, division, multiplication, addition, and subtraction. So here, for brackets, we don't actually have anything we can do inside the brackets because x and 3 can be combined. What we can do is start with our exponent. So we've got x minus 3 squared. So let's take a look at that. This is something that people tend to mess up a lot, so it's worth paying careful attention to. The instinct for a lot of people when they see x minus 3 squared is to say, okay, that's x squared, makes sense, minus 3 squared. That is wrong. Do not do that. So if you think back to last year, and you think back to what you know of exponents, x minus 3 squared means x minus 3 times x minus 3. If you want to multiply two binomials like this, don't forget you need to FOIL, which means you need to do x times x, you need to do x times negative 3 times x, and negative 3 times negative 3. So we've got x squared minus 3x again, and plus 9. Or if you simplify that down, x squared minus 6x plus 9. So going back to our function, we've got y equals 2 times x squared minus 6x plus 9, and then plus 1. So following BEDMAS, our brackets we still can't do anything with. The exponent is gone. No division, but we do have a multiplication. So remember out front here, that's 2 times everything in the brackets. And once again, we need to distribute. So we're going to do 2 times everything in those brackets. So we get 2 times x squared, which is 2x squared, 2 times negative 6x, which is negative 12x, and 2 times 9, which is 18. And then we still have that plus 1 at the end. Don't forget that. So to finish it off, we're going to combine the 18 and the 1 to get our final answer, which is 2x squared minus 12x plus 19. And so we've taken our quadratic in standard form and we've converted it to, we've taken our quadratic in vertex form and we've converted it into standard form. So we'll try one more of these. You can give it a shot on your own and come back and check to see how you did. So the one that you're going to work with is y equals negative 3 times x plus 2 squared plus 4. Be careful with your negatives, give it a shot, and then come back once you're done. Alright, so if you've finished this off, let's see how you did. So we've got negative 3. Again, to square, we're going to FOIL that bracket out. You'll end up with x squared plus 4x plus 4. And then we also have a plus 4 at the end. You need to distribute that negative 3 through. So you get negative 3x squared minus 12x minus 12 and plus 4. And then you're going to combine those last two terms to get your final answer, which is y equals negative 3x squared minus 12x and minus 8. And there we are. So we have now converted our quadratics in vertex form into standard form. Next up, we're going to learn how to go the other direction so that we can draw graphs and other things more easily.